Examining the main function decomp. If we return to main more than one time, it'll exit. It opens proc self maps and parses it in a way that when it's returned, it only shows us the base address of the binary. It asks for three things: an exit status, an address, and a character. We can write to any address, and whatever that address is pointing to, we can write to its LSB. In this snippet, we can see that we can write to any address and overwrite whatever pointer it's holding, but only one character. By searching for the offset of the start of the GOT-PLT section of the binary in Ghidra and adding that to the base address of the binary, we can view the GOT-PLT section in the binary with GDB. The third quad word here is DL runtime resolve. We will utilize the fact that we can write to the LSB of any arbitrary address we choose to. We choose DL runtime resolve, bypassing the part where it stores its register stashing and adjusts the stack, causing it to restore registers with data that partially overlaps our buffer instead. The technique employed is only possibly due to the architecture being ARM. The register stashing would be completely different on other architectures. We start off with some initial pwn tool stuff, and then we rebase the binary with the given leak from proc self maps. We calculate the address of DL runtime resolve, and our jump byte will be AC, bypassing the register stashing. So we're going to jump right here. We send our first payload, which jumps us to DL runtime resolve. We send the address of puts, which ends up in x0. We skip over x4 through 9 and the stack pointer. And then we send the GOT address of printf, which ends up in x17. And the return address of printf will be back to main, but skipping over the main return check, which ends up in x30. This will give us a puts leak, so we can rebase libc. We get the address of bin.sh, and then our second payload, we will do the same thing. We'll fill x0 and x1 with bin.sh, the address of it, and then we'll pad out the rest of the buffer, skipping x4 through x9 and the stack pointer, and then calling string so that the address of bin.sh will get called for system as an argument to system. Starting off with some vulnerability analysis. The buffer overflow is obvious, so we won't talk about it. In case 1, our first input is an integer that is then turned into a pointer. We can feed this input the win function as an integer. Our second input is the upper limit for the loop. If the depth is 0, the loop won't execute, and no dereferencing will be attempted. In case 2, we have an out-of-bounds write. We calculated the offset between minecarts, which is where our input is stored, and the return address of the main function. When case 4 is called, it jumps to done. Done will jump to the return address, which is, in this case, win, since we will overwrite it. Calculating the offset between the return address and minecarts, and getting the flag. So starting off with some initial pwn tool stuff, and then we create the wrapper functions for malloc and free, and the use after free. We make 2 chunks, the filler chunk so we can gain an actual FD on the second chunk, and our chunk we will be using for our use after free to T-cache poison. We free both chunks, and then we overwrite the FD puts, we overwrite the we free 2 chunks,
and then we overwrite the FD with puts got, and then we remove chunk from tcache and overwrite puts with the win address.